Hello students. So here we are with the third lecture of some basic concepts of chemistry. In this we will be studying laws of chemical combination. The first law is law of conservation of mass. So as the statement says, during any physical and chemical change, mass can neither be created nor be destroyed. Now let's take this example of formation of carbon dioxide. Carbon burns in oxygen to form carbon dioxide. So the weight of carbon is 1.2 gram, oxygen is 3.2 gram. So the mass of the reactant total is 4.4 gram and the mass of the product is also 4.4 gram. That means total mass of reactants is equal to the total mass of products. So that is what is law of conservation of mass. Whatever mass you have taken in the reactants, you get the same mass in the products. So that is mass can neither be created nor be destroyed. So Antonio Lavoisier presented this law, stated this law of conservation of mass, which says that that mass can neither be created nor be destroyed. So here you see before the reaction mass is taken, after the reaction mass is taken, and total mass of reactants is equal to the total mass of the product. So before the reaction and after reaction, the masses are coming to be total masses are coming to be same. Now law of definite proportion. Law of definite proportion says that the given compound always contains exactly the same proportion of elements by weight, irrespective of the source of preparation of method of preparation. So validity of this law has been confirmed by various experiments, and this law is sometimes referred to as a law of definite composition. So here you see water. Water may be obtained by any method, by from the spring water, from the sea water, from the lake water, whatever source of water may be obtained. The amount this hydrogen and oxygen as is in the same proportion. So hydrogen will be always 11.19% and oxygen will always be 88.981%, irrespective of the source from which the water is obtained. Similarly, carbon dioxide, whichever source it is obtained, the percentage of carbon is going to be 27.27% and the percentage of oxygen is going to be 72.72%. So whichever source this carbon dioxide is obtained, irrespective, the percentage of carbon and oxygen in the carbon dioxide is going to be definite. So that is a law of definite proportion. Then given this law was stated by Proust, and he said a given compound always contains exactly the same proportion of elements by weight, irrespective of the source. A given compound always contains the same element in the same proportion. So, for example, cupric carbonate. Cupric carbonate can be obtained by the natural sample or can be obtained by the synthetic sample. The percentage of copper is going to be same 51.35, percentage of oxygen is going to be same 38.91 and the percentage of carbon is going to be same 9.74 irrespective of the source it is obtained from. So law of multiple proportion was proposed by John Dalton in the year 1803. He said that when two elements A and B form more than one compounds, the masses of the elements B that combine with the fixed mass of element A are always in the simple whole number ratio. Okay, let us see the illustration and understand. So law of multiple proportion states that when two elements combine to form more than one compound, the mass of one element which combines with the fixed mass of other element will always be ratios of whole numbers. So here you see the carbon is forming two oxides, carbon monoxide and carbon dioxide. So mass of carbon is 12 grams in both the cases and mass of oxygen is 16 grams in the first case and carbon dioxide it is 32 grams. So the ratio of oxygen in these two given compounds will be 16 is to 32, that is 1 is to 2. So this is law of multiple proportion is proved. So what is the law saying? Let's see again. When two elements, which are the two elements here, carbon and oxygen, combine to form more than one compound. What compounds it is forming? Carbon monoxide and carbon dioxide. That mass of one element, which combines with the fixed mass of other element, will bear a simple whole number ratio. So mass of one element, that is oxygen, in the two compounds is combining with the fixed mass of the first element, bears a simple whole number ratio. Okay, clear? So the whose mass is changing? Mass of oxygen is changing. Whose mass is constant? Carbon mass is constant. So the ratio of oxygen in these two compounds is a simple whole number ratio. Clear? Now see the another example here. Hydrogen and oxygen is forming two oxides, water and hydrogen peroxide. Whose mass is constant here in the two? Hydrogen is 2 grams. But oxygen is what? 16 grams and 32 grams. So the different masses of oxygen that combined with fixed mass of hydrogen will bear a simple whole number ratio. So here it is found that two masses of oxygen are 16 grams and 32 grams, which combined with fixed mass of hydrogen, that is 2 grams. So they bear a simple whole number ratio, that is 16 is to 32 and 1 is to 2. Another example, here you see nitrogen and oxygen are forming two oxides, nitric oxide and nitrogen dioxide. Formula of nitric oxide is what? NO, and formula of nitrogen dioxide is what? NO2. So whose mass is constant here? The mass of nitrogen is fixed 14 grams in both the compounds, but oxygen is changing. Oxygen is 16 grams in the first case and 32 grams in the second case. So the different mass of oxygen that combines with the fixed mass of nitrogen bears a simple whole number ratio. So the two masses of oxygen 16 gram and 32 gram, which combined with the fixed mass of nitrogen 14 grams, are in the simple whole number ratio, that is 1 is to 2. Correct? Similarly, sulfur can combine with oxygen to form two oxides, sulfur dioxide and sulfur trioxide. So different masses of oxygen that combine with fixed mass of sulfur bears a simple whole number ratio, and that ratio is 2 is to 3. Got it? Gay-Lussac's law of combining volume of gaseous volume. So when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So this law was put forth by Gay-Lussac in 1808. So let's see what does it mean. So when gases combine, react with each other, the simple ratios of their volume, and if the product form is also gaseous, then volume of the product also bears a simple whole number ratio with a gaseous reactant. For example, here you see hydrogen reacts with chlorine to give you 2HCl. So one volume of hydrogen reacts with one volume of chlorine, giving you two volumes of HCl. So the ratio will be what? 1 is to 1 is to 2. Then 2SO2 plus oxygen gives you 2SO3. So here you see two sulfur dioxide volumes, one oxygen volume reacts to give you SO3 volume of two volumes of SO3. So their ratio will be what? 2 is to 1 is to 2. Then nitrogen, one volume, three volumes of hydrogen reacts to give you two volumes of ammonia. So the ratio is 1 is to 3 is to 2. So, provided the measurement of all volumes are done under similar conditions of temperature and pressure. I hope it's clear. So, when the gaseous reactants react to give the gaseous product, then their volumes bear a simple whole number ratio, provided the volumes are measured at similar conditions of temperature and pressure. So, that is Gay-Lussac's law of combining volume. So here you see in this example, nitrogen gas plus hydrogen gas gives you ammonia gas. So the ratio of the volumes will be one volume of nitrogen reacts with three volumes of hydrogen, giving you two volumes of ammonia. So their ratios will be 1 is to 3 is to 2. Now this is a question. 15 liters of nitrogen is made to react with 30 liters of hydrogen to prepare ammonia. Calculate the composition of the resulting mixture. So here we'll first write the balance reaction. Nitrogen is reacting with hydrogen to give you ammonia. So one volume of nitrogen reacts with three volumes of hydrogen to give you two volumes of ammonia. So by Gay-Lussac's law of combining volume of gases, the ratio of nitrogen to that of hydrogen is what? 1 is to 3. So in this case, hydrogen is the limiting reagent and nitrogen is the excess reagent. So here you see 3 into 10, that is 30 liters of hydrogen can combine with 1 into 10, that is 10 liters of nitrogen to give you 20 liters of ammonia. So thus the unreacted nitrogen will be what? 10 liters have reacted. So how much was initially? 15 liters. So unreacted will be what? 15 minus 10, that is 5 liters. And this resulting mixture will contain what? 20 liters of ammonia and 5 liters of unreacted nitrogen. Clear? So 15 liters of nitrogen was taken and 30 liters of hydrogen is taken. Okay? Clear, no? So 1 volume of nitrogen reacts with 3 volumes of hydrogen, giving you 2 volumes of ammonia. So let us take this 1 volume as 10 liters. Okay. So 10 liters of nitrogen reacts with 30 liters of hydrogen, giving you 20 liters of ammonia. So what is formed in the resulting mixture? What is there in the resulting mixture? 20 liters of ammonia and 30 liters of hydrogen is reacted, and this was 15 liters taken and 10 is reacted, so 5 is remaining. So unreacted nitrogen is 5 liters and 20 liters of ammonia is formed. Yeah. Now Avogadro's law. Avogadro's law was proposed in 1811 by Avogadro, and according to this law, equal volume of all gases at same temperature and pressure contains equal number of molecules. So if it is equal volumes, they'll contain equal number of molecules. So Avogadro's law, the balloons all have same volume. This means they contain equal number of molecules. So here you see the balloon is filled with hydrogen, nitrogen and oxygen. Their volume is same. So that means the number of molecules will also be same. Okay. So if we consider the reaction of hydrogen and oxygen to produce water vapor, reaction is what? H2 plus O2. 2H2 plus O2 gives you 2H2O. So here you see 100 ml of hydrogen reacts with 50 ml of oxygen, giving you 100 ml of water. So 2 volumes of hydrogen reacts with 1 volume of oxygen, giving you 2 volumes of water. So if we as we said, volume is directly proportional to the number of molecules. So instead of volume, we can write the molecules also. So 2 volumes will contain 2 n molecules of hydrogen, n reacts with n molecules of oxygen, giving you 2 n molecules of water. Or we say 2 molecules of hydrogen reacts with 1 molecule of oxygen, giving you 2 molecules of water. Okay. So 2 volumes of hydrogen reacts with 1 volume of oxygen, giving you 2 volumes of water. Now let's find out Avogadro's law equation. Now there are few ways to write this gas law, which is a mathematical relation. It may be stated as K is equal to V by N. So as we said, V is directly proportional to N. So V is equal to what? Kn. So K is what? Proportionality constant, where V is the volume of gas and N is the number of moles of gas. Okay. Now according to the gaseous ideal gas equation, PV is equal to nRT. So if we take two conditions, P1, V1 and temperature T1 and number of moles, N1 is the number of moles, and the second condition it is P2 pressure, P2 volume and T2 is the temperature, new temperature, and N2 is the number of moles. So to equate this, it will be P1 V1 upon T1 N1 equals to P2 V2 upon T2 N2. So P2 and P1 temperature T2 and T1 are same. So we can reduce it to V1 upon N1 is equal to V2 upon N2, or we can say V1 N2 is equal to V2 N1. So where P is the pressure of gas, V is the volume of gas, T is the temperature of gas, and N is the number of moles. So here because pressure and temperature was same, it got cancelled. So therefore V1 upon N1 equals to V2 upon N2. Implications of Avogadro's law. So molar volume of all ideal gas at 0 degree centigrade and 1 atmospheric pressure is 22.4 liters. If pressure and temperature of gases are constant, when the amount of gas increases, the volume increases. If pressure and temperature of a gas are constant, when the amount of gas decreases, the volume decreases. So you prove Avogadro's law every time you blow up the balloon. Okay. So volume is directly proportional to the number of molecules, provided they are measured with the same pressure and temperature conditions. Okay. So the first implication is that the molar volume of ideal gas at 0 degree centigrade and 1 atmospheric pressure is 22.4 liters. So the example, say you have 5 liters of a gas which contains 0.965 mole of molecules What will be the new volume of gas if the quantity is increased to 1.8 mole, assuming pressure and temperature constant? So our formula was what? V1 N2 is equal to V2 N1, with the value V1 is what? 5 liters and N2 is 1.8 moles. So you have to find out the new volume, V2 you have to find out, and the number of moles, first number of moles will be 0.965. On solving this comes to be 9.33 liters. Okay, clear? I hope the laws are clear. Thank you.